Hi, my name is Julia Bryden, and today I'll be talking about my project on Lyapunov-based control for SCP initial guess generation. My goal for this project is to implement large divert guidance, where the objective is to minimize fuel usage, subject to a list of state constraints and control constraints. State-of-the-art guidance algorithms use sequential convex programming to solve a sequence of local convex approximations to the non-convex guidance problem. In order to reduce the number of iterations required to converge to a solution, I propose to create a new initial guess strategy that no longer uses the currently implemented straight line interpolation method, but instead utilizes an asymptotically stable initial guess strategy formulated using Lyapunov theory. This project is broken into two parts. First is implemented in Tedrake, where the dynamics of the system are linearized. S of t from the time-varying LQR is determined. V of x and rho of t are computed for the initial guess. And finally, all parameters are determined using the maximum region of attraction SOS program. From the SOS program, the initial trajectory guess is determined, and the penalized trust region solver is used to compute the final trajectory. First, I linearized the system dynamics into the A and B matrices, and then I determined a trajectory that would be used to find the region of attraction and Lyapunov function around. Using the linearized matrices A and B, I was able to compute S of t for each time step using the linear quadratic regulator equation. The Lyapunov function guess was determined by multiplying x bar, which is x minus the initial trajectory, by S of t from the LQR. For the unconstrained Lyapunov control problem, I implemented the time-varying controller design shown in steps 1 through 3. And in step 1, you can see the solution to U bar as implemented in the system dynamics. I was able to get a solution using penalized trust region, and the final solution resulted in about a 6% SCP runtime reduction. From this project, I was actually surprised that determining a Lyapunov function is actually pretty difficult. In addition, the number of constraints and alternations for a more complex system grows pretty quickly. For future work, I plan to extend this algorithm to be implemented with less memory constraints as well as expand to 3 dimensions.